Hello, welcome to class. Before every lesson, please pray. Make sure you have your pencil, pen, notebook, and some homework pages out so you can make sure you know what you're doing. Make sure you have a notebook for the entire algebra class so that way you keep using the same one to take notes. The overview of the unit, we are going to learn what God has to say about many things in the Bible. In this unit, we talk about expressions. You need to realize that God expresses himself in words all the way through his entire word. He shows himself in his written word. And I love this quote from Tony Evans. God expresses himself to you, through you, and in you. He wants you to know that expression is full of love because God is love. So we're going to start with rational and irrational numbers. These are the numbers that are basis of whether or not you have an integer and all of those nice words. So our objectives are going to be classify real numbers as rational or irrational according to their definition, state examples of rational and irrational numbers, and then we're going to talk about the sum and the multiplication of rational numbers versus irrational numbers and explain why the sum of a rational number and an irrational number is an irrational number. Okay, so here's some definition of what words I'm using. Real numbers, the set of all numbers, both rational and irrational. The sets are kind of like a collection or a group of things. Subset is part of that set. Rational numbers, there are numbers that can be expressed as fractions. They're typically a decimal that are repeating or terminating. Irrational numbers cannot be expressed as a fraction, and they don't repeat. They just keep going on forever and changing. The biggest and most popular irrational number is pi, which is the 3.14 ... So this is a kind of game I like to play, and it's riddle me this. I want you to pause the video and see if you can answer these as a yes or no. And we're going to kind of go through them and see if we can do that together when you come back. All right, welcome back. The set of 0, 5, 11 can only be labeled as natural numbers. Well, 0 isn't a natural number, okay? If you look here, my natural numbers have 1, 2, 3, 4. They're counting numbers. My whole numbers have 0. My integers have 0, 1, 2, 3. And my real numbers, as well as my rational numbers, have 0, 1, 2, 3. So this answer would be no, because first of all, natural numbers don't have 0, but everything else except for irrational numbers does have 1, 2, 1, 5, and 11 in them. What about a number with a repeating decimal? Now, I mentioned that earlier is the set of rational numbers. Is this true? It is, because I can put 0.3 repeated, which is 1/3, but any repeating number that actually is, or that ends a decimal like 0.625 is considered a rational number. So this would be yes, and this would be no. Irrational numbers go on to infinity and beyond. That is true. Actually, to this day, we still haven't found the end of pi. So everything that continues to go, like this one right here, you'll see has no repeats. They are considered irrational numbers because they don't end anywhere. So this would be correct. So what about categorizing this set? I have a -1, a -3, 3. I have a square root of 7 and 14, 25.56. So we're going to start with this -1. Well, it's not a natural number. It's not a whole number because those can't be negatives. And it could be an integer, a real number, or a rational number, but it can't be an irrational number. So then we have this -0.33. So that eliminates my integer, but the square root of 7 is what's really throwing me, because what is the square root of 7? Well, it actually is considered an irrational number because of the fact that it doesn't, your real, like the square root of 16 would come out as 4, the square root of 9 would come out as 3, but the square root of 7 is an irrational number. So the category for this is only one thing, and that is all real numbers. For our God moment, God is irrational to the world standards. What we need to realize is irrational goes on forever. It doesn't make sense, doesn't repeat, but we have an infinite God. We think finite, logical, and so we don't really understand his unfailing love, which is irrational. So to the world standards, God is irrational, but we know that he loves us. He died on the cross before we were even born. This makes no logical sense. It is extremely illogical or irrational to the world standards of our rational thinking. So we need to really think about the fact that God is not something we can rational out to be a repeating decimal or a fraction, okay? He is going to go on forever, and we will never fully understand him until we are in eternity and when we're with him. So without God, we cannot, without Jesus, we cannot explain or understand or even comprehend God or eternity or any of it. We are humans, we have finite minds, we just don't get it. So if you think of it that way, I love it. And I love this verse, for the foolishness of God is wiser than the human wisdom, and the weakness of God is stronger than any human strength. 1 Corinthians 1:25. It really explains that so much better. All right, on this case, which of the following examples are rational numbers? Remember, they are finite. I want you to pause the video, circle all the rational numbers, and see if you get it right. Welcome back. Here are my rational numbers. These three right here are irrational, so they would not be the case. So hopefully you got that right. You'll notice this is a repeating decimal. So that's why. Good. We're going to talk about what the word irrational actually means. Have you heard of this word before? What is it usually associated with? How might this relate to the world, to numbers in the math world? Okay, where do you kind of see irrational numbers? Well, this is kind of hard because you think of it as like pi, square roots. Where would you see the pi is used in finding the area or the circumference of a circle? So you might use it in a construction type thing, or if you're a woodworker. So that's typically what irrational is associated with. What classifies a rational number? It's kind of think about it, pause the video, see if you can write some out. Rational numbers are seen everywhere. They typically are you've seen them as integers, 1, 2, 3, 4, 0, -1, -2, -3. But they're also 0.3 repeated, which is 1/3. Any fraction, so something like 21 divided by 28, okay? Those would be irrational numbers. You reduce that. Okay, so let's practice. What I want you to do is I want you to fill in the little table here. So you're going to pause the video and see if you can do it. You're going to tell me, is this an integer? Well, the very first one, you'll notice it's 1.6, and the answer is no. Is it rational? Yep, it's rational. It's not irrational. And where is it on the number line? Okay, so here's my 1, here's my 2, here's my 3, and here's my 4. See if you can find the rest. We have H for you, so we're done with that one. But see if you can figure out where the rest are. And you may have to think a little bit, especially with the square root of 5. Remember, the square root of 4 is 2. That may help you. Pause the video and see if you can answer it. Here is the answers for this. So hopefully you got them right. These are no, 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 no. They're not right. They're integers, but this would be because that is actually 3. And the rest of them are. And you'll see that this is rational, rational, rational. The rest of them are, and there's all of where they are on the number line. Hopefully you got all those right. Adding and multiplying rational numbers. So we're gonna get our thinking caps on. Will the sum of two rational numbers be rational? So I want you to come up with two rational numbers, add them together, and see if that's true. Pause the video, and then we'll come back. I chose some fractions, okay, and mixed numbers. You could have chose just like 2 plus 3 and seen that that was 5. But I decided to go ahead and show you in a fraction. So if I add these guys together, remember these guys have to be common denominators. So I added them all together and I got 1 and 1/40, which is a fraction, which is, you'll notice, an ended or terminated decimal. And then I did mixed fractions and I turned them into improper fractions. Same denominator, added them together, and I got this. So you'll notice that is true. So this one would be yes. Okay, in this case, put your thinking caps on. Will the product of two rational numbers be rational? You want to make sure product means multiplication. Okay, so think of two rational numbers. Remember, 2, 3 is fine, but try some other ones as well, maybe some negative numbers or some decimals to see if this is true for all things. Pause the video, see if you have the right answer. And here you go. The answer is yes. So hopefully you got that. I did take two fractions. And when you multiply them, if you can either multiply them across by 2 times 5 and 5 times 8, or if you are a little more advanced, you can actually realize that 5 divided by 5 is 1, and 2 goes into 8 4 times to give me 1/4 right away. Here we go again. Here's some mixed fractions. Here they are here. Doesn't look like anything goes into each other, so we're good. So I have 171 over 64. I turn it back into a mixed number and I can put it in decimal. By the way, this does end. This is the end, okay? It doesn't repeat anymore. So let's put our thinking cap on. Will the sum of a rational number and an irrational number be a rational or irrational? Decide if the answer is going to be rational or irrational. The answer is it will be an irrational number. So this would have been the correct answer because I have a rational number and it just kind of gets encompassed inside my irrational number, but my irrational number doesn't end. And here you go. I tried the square root of 8 with it, and there I go. It just goes on forever. All right, let's try another one. Will the product, which is multiplication, of a rational number and an irrational number be rational or irrational? Let's think about this. Give me a check or an X, which depending on which one's correct. Try some examples. Pause the video. The answer is it will be irrational because, again, I'm multiplying and it's just encompassed inside of this wonderful big long number, and it makes a smaller number. Same with 19 times the square root of 8. It's just a big number times 19, so it just makes it a bigger ugly number. Let's try another one. Challenge on. Think real hard. If you subtract a rational number and an irrational number, will the answer be rational or irrational? Pause the video and see if you can come up with some examples and find the answer. Answer is still irrational. Just like addition, it just kind of now comes away from that and make it smaller, but it still is a irrational number. All right, let's try another one. If you divide a rational number and an irrational number, will the answer be rational or irrational? Pause the video, see if you can come up with examples and see if you can come up with an answer. All right, the answer is irrational. Doesn't matter what I do to this poor little irrational number, it ain't changing. Nothing I do to an irrational number is going to ever make it a rational number. Here is a recap. Rational plus rational equals rational. Rational times rational equals rational. If I multiply or add an irrational number with a rational number, I will always get an irrational number. So the next thing I want you to do is I want to talk about putting it on a number line. I want you to do A, B, C, 1, 2, 3, put them on this number line below here. Pause the video and see if you got it right. Here are the answers. If you don't know where they are in the number line, you do need to probably review some of that, find some information online. This should be something that you've done in the past as far as working with a number line. What about this one? These are irrational numbers. They're harder to do. I just remember the square root of 1 is 1. The square root of 4 is 2. And that may help you figure out where these guys are going to sit. Pause the video, see if you can answer it. All right, there are my answers. Hopefully you got them all right. You'll notice none of them are on any of the whole numbers, but there's somewhere between. Here is an activity that you can do. Try it. It's a proof of irrational numbers. I want to see. And it will actually walk you through it, see if you can kind of move it around a little bit. I'll have a small little video in the classroom that actually goes over it. And hopefully you did well on that. And your homework is assignment 1, unit 1. Exit ticket. I always give an exit ticket at the end. It says name all the number systems to which this one belongs. So think about what the square root of 25 is. Hopefully you've seen it in the past. And see if you can answer it and pause the video. It actually ends up being A because that is 5.